Does it work? Yeah. 1 more minute. Yes, I'm ready.
Okay, we begin?
Yeah, did you an introduction?
Yes, I just...
Okay, good.
So, welcome everybody. Thanks to be here for the speech of Mike Muller. We will talk about Python, of course, and very special usage of Python for fast calculation, fast process. Just a little bit of housekeeping. It will be 35 minutes of speech, and then for the question it will be at the end 5 minutes. So if you have any question, please take notes and we will go through the Q&A session. Now I'll leave the speech to the expert. Thanks.
Thank you for the introduction. Hello everybody to the talk Python is faster than Fortran. So we see how this goes. Just a few words about the motivation. So as you can see there, the logo, I work as a Python trainer and do quite a bit of Python training. And a rather big part of my students are scientists and engineers. So they're not professionals by trade, they're just scientists that happen to program. And that's because for them speed is very important for many of their problems. They do very large numerical calculations very often, and that might take hours and days or even longer. And those speed, it's very often the main concern of scientific programmers for a lot of their problems. And Fortran is still used quite a bit in this area. So there are some areas in the scientific area that Fortran it's a main programming language. So like atmospheric science, I think it's quite a bit. Also other areas of research and engineering, Fortran has a very strong stand besides C. So that's a motivation. So Fortran is one of the oldest programming languages. To my knowledge, it's just emerged in 1954. So if you look at this, there's a very nice flowchart from O'Reilly about the history of programming languages, and Fortran is one of the very left-hand side. It's formula translator, so it's primarily designed for mathematical problems. So scientists have been concerned traditionally with solving mathematical problems. They formulate their problems as mathematical equations in one way or the other, and then they try to solve it. And Fortran has the reputation to be fast. Fortran has been designed as a language to be fast. It's very close to the hardware, so to speak, but still it's not assembled. You don't have to talk in computer terms. You just try to formulate your problem in a kind of a mathematical notation. And in this area, commercial compilers play a big role. There are some free ones like Fortran, but there are a bunch of commercial compilers, and one of their main selling point is speed. So everything has to be fast, 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 fast. And then you get very big compilers. The download of the compilers is 700 megabytes very often, and they try to optimize the heck out of your code and do a lot of things. And Fortran itself is, all the design principles always have speed in mind. They do Fortran. For instance, there haven't been pointers in Fortran for a while now. Since Fortran 90, they have pointers, but if you have a pointer, you have a target, just to give the compiler enough room to optimize things, those kind of things. Okay, that's Fortran. Python, everybody knows Python, so I'm preaching to the choir here. Python has a reputation to be slow. Yesterday I gave a tutorial, half-day tutorial about optimizing Python code. Though Python, of course, it's translated to bytecode, and everything is an object. So every time you do a numerical calculation, one way or the other, you work with an object, and this can be kind of expensive, or pretty expensive. So Python can be easily 1 or 2 orders of magnitude slower than the same thing in Fortran if you do numerical calculations. So depends very much what you're doing. So if you do string processing, you might not see the big differences, but if you work with numerics and do a lot of calculations for many hours, then Fortran will usually typically much faster. So, and then but there are a lot of solutions in Python to do this. NumPy would be one, and a lot of the other things, SciPy, a lot of other packages that are associated. They are written in C, and Fortran actually, and you access them from Python. That's a normal way to do it. You don't reinvent the wheel. You just take the tools that have been there for decades and you wrap them in Python in Python. But today I would like to talk about a different problem. Actually, this is a very small problem, and there are two solutions I will show you. So the problem is you have you want to find the common coordinates in two collections of coordinates. So I'll show you an example in a minute. You have two collections of x, y, z coordinates. And these are two columns, and they are on two files. Like you have two big files with coordinates, and we would like to find out which ones are on both. That's the task. So it's something very simple, actually. And it's a solution. So we look for two solutions. We have a solution in Python, and we have a solution in Fortran. And I'm looking for typical solutions. So it's not a scientific comparison of algorithms. It's not a scientific comparison of algorithms, but rather what an average programmer who uses this language, so an average programmer for me would be a scientist or engineer who knows enough Fortran. And most of them they know Fortran 77, a little bit Fortran 90. Nowadays the newest version is Fortran 2008, but I think there's no compiler yet that really supports everything. And though a typical user of this language, what he or she would do. And therefore there's no direct comparison between the algorithms, but rather about the approach, how you solve a problem and how you get your solution. So I would call it a real-life comparison, so or a comparison of practices. We just had a discussion. Okay, that would be sample data. So this would have two files that look just like this, just some random numbers x, y, z in here. And now you have two files and just want to figure out which of this coordinate x, y, z tuples, if you talk in Python terms, are on both of those sample data. That's a simple task you want to do, and you will see two very different solutions in Python and Fortran for the same thing. Okay, this is my the first part of my Python solution. So this is a Python program. In the first part, you have to read the files, and in Python reading files is pretty easy. You see here, it's a function read file. You give it a file name. You just open the file with a with statement, as you should do if that makes sense. It makes sense here. I open a with statement, I get a file object. I skip the first line. I just skip the header because I know it's XYZ. In Python it would be very easy to identify the column by name, but I just skip it. And I make an empty list and go to the file object and just fill it. And as you can see here, I just go through every line, split the line at a white space, convert every entry to a float, and put those things in a tuple that I can do everything and append it to data. So if you look at this here, you see already that's a more traditional approach, making a new list and putting things in, which is fine. But in Python nowadays we have list comprehension, so you can make these things even shorter. So this would be equivalent in terms of what it's doing, but you save 2 lines, because now I just forward the first line and then I do everything in one line. So I use this, actually it's a generator expression here, and I go through every line in the object, split this line, take every entry in this line, convert it to a float, and all the 3 floats in there will be a tuple. And I just do this for all of the lines in the code and get this back. So it's a little bit harder to read, but it's 1-2 lines shorter, whatever version you prefer. But it's pretty easy, pretty simple, and you read your file. That's the first thing. The second part, it's surprisingly simple in Python. The Python solution is kind of very, very simple, because now I get just 2 file names with my coordinates, and I just call the function we just saw. Twice we read the file, and from this one returns a list. I said I just return a list because it's a more general case. I convert this list into a set, and I have 2 sets, and I just do the intersection of the set. That's 3 lines to do it, but if you write them, you can make it even shorter. So the whole thing, the whole longer version, would be 30 lines of code. And now I also make the second version a bit shorter, which is very easy. So instead of intersection, I use this ampersand here, which is the same thing. So it's overloaded, and I just say set read file name, set read file name 2, and return it. So it's a one-liner. That's the whole thing. It's one line on Python, and makes it a whole lot of 8 lines of code in Python. So not counting the comments. Okay, that's what we do in Python. Now we do the same thing in Fortran. In Fortran, it's a bit longer to do this. So in Fortran, you need to define subroutines to do this, and there's not such a convenient way to read a file. So in Fortran, you have to, if you want to read a file, I would need to allocate an array to put my data in. But I need to know how big the array is, so I have to read the file twice. I read the file once just to count the lines. This is what I'm doing here. And this subroutine is just counting the lines, and I have to split the thing in 2 parts, otherwise it wouldn't fit on the slide. So this is my subroutine that counts a line, that takes a file name, and the subroutine doesn't have a return value, so you have, this is pretty much my return value. So, but in Python you would return, you have to give it a, in this case an integer, that will be filled with a value. And then I have to do all this declaration first, implicit none, that means I have to type everything, there's no implicit typing. So otherwise everything starts with KLM, would be an integer, but I do explicit typing, so implicit none. And I have this intent out here, which is Fortran 96 syntax, and I want to return this one. I have a status for reading my file. I have 2 characters here. One is a length of the flow. The file name shouldn't be longer than 20, so I have to know this. In this case, I know. If it's not, I have to make it bigger. And I have a dummy character, which is just a dummy because I need to read my file to count the lines. And then I go through. That's the whole thing to reading this file. So, you know, this open 4-line and file in Python. This one line, that's this. And then I need to open, I have to explicitly give a unit number, give it a file name, status old means the file exists, and I want to read it. And then I just read it. And if the status is not 0, then have to exit, then I'm done. And see, I read everything in the dummy. And then I increment my line number by 1. So that means I read all the lines and just increment and see how many lines I have. If then there's the status, that's an error message. There's no exceptions here, so I have to check manually if there's a status, if there's something wrong, and I have to say there was an error. Which one, I don't know, but it was an error, there was something wrong, and it just write out the line that happened, an error happened when I read it for some reason. And then I just say, I take one line off because I don't want to count the header. So just at the end I decided to take one line off at the end, and I close my file. So this is just to count how many lines I have. The Fortran is a little bit more verbose than Python, obviously. And then I do the same thing again, and now I need to read my data and have to do the same game again. I have to have a subroutine that takes a file name, an empty array, I haven't seen yet, the lines and the rows, that's 2 integers, and I do have to do a lot of declarations. You see, they're intent in, they are in. I have a status again, then a line, which is an integer counting the lines. And then I have a double precision array, so double precision would be floats in Python, and I have to define a 2-dimensional array with lines and rows, which will take up my things. This will be my data array, which I will create here, and then I have intent in the file name and have again a dummy. So all those declarations I have to do to get these things working. And then, excuse me? Do you need also an intent for the data array? Actually, yes, but it works without. But you should say intent out, I think, because that's where you put your data and it will be intent out. I've forgotten here, but it still works. No, because I think I allocate the thing in here. Actually, I have to look. I've forgotten how to do it. You see in the next slide how I do it. It should be an intent. I don't allocate. I just put it in. I allocate it outside. Otherwise, it wouldn't work. So I do the same thing again. I open the file. I read the first line because there's a header. I skip it, and then I go through. And of course, now I know my number of lines. I know how many I need to read. You can do this. It is a different thing also here. And now I go through and read everything. You see, that's one line. So I read everything, and the left column goes in. Fortran is indexing sorting at 1, not 0. So 1, column 2, column 3. And again, if the status is not 0, I exit and go out of here. So So I just assume nobody else changed the file in between because I opened it twice. So I can save a little bit of this error checking things here. Okay, that's just the rate of the data. Yeah, this is our 3 lines of Python just blew up a little bit here. And now I have the next one. Now I will find the intersection. So there are no sets in Fortran, and I looked around. I couldn't find an implementation of sets, and the one I found is also not better what I'm doing here. So now I have this intersection thing which gets very big. As you can see, I get 2 data arrays, data 1 and data 2, which I read. We see the main program in a minute, and the lines and the rows, and have to do this all this declaration stuff again. You see this getting quite a few lines. What I'm doing here, this is very similar. I get these integers here in and the number of rows in, though, and then I read those things, and and I read through, and then I have to have 2 arrays here. Now it's intent in. You see, I get those arrays, and they are 2-dimensional, and I have to define the dimensions. So all the things I have to do to get there, and then I have to make an allocable array. So I can allocate this one. This will be a temporary array I'm using here. The same thing for this one. So I have 2 temporary arrays to store my results. Still not done yet. And then I have to, when I read this one, if the set is a 0 here, if the allocation then had the allocation error. Okay, so this would be the first one. And then now I'm redoing the intersection algorithm. I go through all the lines, and now I get a very nice quadratic algorithm. So I go to the first set of data, to all the lines, and then to the second set, and I check if they match, and I just check if line 1 is the same, the column 1 and my array 1 matches the column 1 there, and so on. So I go through 3 rows here. This all the rows. So I go through and check if they match. And if all 3 of them match, then they are the same. So that's what I'm doing here. And I check it has the same output as a Python program. And then what I do then, I put those ones in this temporary array. And this temporary array has to be as big as the biggest one of these, because potentially all of them, all the coordinates could be or the smallest one actually could be in both. So then I have to make it big and go through, and I do all those loops and close all those loops. You see, that's still not finished. And then I have to allocate, and of course now in the end I want to have an array which just has my found elements. In my case, it's just 3 or so of elements that are the same, and then I make just another array to allocate again, make it shorter. I of course now can allocate it here because I know the number, how many are in, and make a short array. So the thing is now, this one is just a subroutine. I don't even have the main program yet. Of course, with Fortran 95, you don't have a way to do this dynamic allocation in a subroutine and return the array to outside. It only works with 2003, which is not so common yet in most places. Okay, I just showed it's a lot of lines that going on here, and now we still need a main program that calls our 3 subroutines we have. Now that's a main program, and again I have to do a lot of declarations here. All those I have to declare these 2 arrays, which I then will hand into the subroutines, and I have to declare the file names here, and then I call my first subroutine. That's the first subroutine we saw that just counts the lines, and I have to call it twice for both of them. So this is the first call, the second call, and then I allocate the array. I allocate this array, and then I call it second call here for the second one, and first I call the count lines for the first one, read the lines, then I call the count lines for the second array, allocate it, and read the data. And then eventually I can call my find intersection one. So even if I don't understand all the details, you see it's a lot you have to do, and it's still not really fully equivalent to the Python one. It's not as elegant. There are a few things I have to assume, lengths of strings and all the stuff, which you don't have in Python. And then now we have about 107 lines of Fortran with all the things. It takes you a lot of debugging because you might make mistakes when you do this allocation things and whatever things through. And 8 lines of Python. And the Python version you can just write down without, if you know Python good enough, you know what sets are, it's a kind of no-brainer to write the Python version. But the Fortran version is so much more involved to do this. It took me much, much longer to write it more than half a day just to figure out how to do this Fortran, everything, how this works. And still, the Python version is still better at doing things. Okay, that's a writing part, though. Obviously, Python wins in this arena. Python is much easier to write here than the typical Fortran. So it's not the same algorithm because in Python we use sets. Fortran doesn't have sets. And I haven't found any sets yet. I haven't even found dictionaries or hash tables in Fortran. There's one implementation, but it's very difficult to understand and very difficult to underuse. It works only with strings as keys and strings as values and has a lot of limitations. So it's very unlikely that people are going to use it because scientific users of Fortran don't know about hash tables, often at least. It's a typical thing. So, okay, now that's a writing part. Fortran wins, Python wins here with a big margin. Now let's look how this thing works when we run it. So we run it with test data. So I have two files with 1,000, 10,000, 100,000, and 1,000,000 lines. And they are not exactly the same. So one file has 5 lines more than the other, just to make it not equal. So to make this case. And then there are 3 coordinates pairs that are guaranteed to be both. But I put them in by hand. So I know. I wrote a small Python script, of course, to generate random numbers, but that's not important here. You have the data. So that's my test case. And now I run this thing. And now you see how fast things go. So for the small test case, you see the red is a Fortran. This is a log scale. See, that's 10 to the minus 2 here, 0.1, 1, 10, 100, 1,000, 10,000, 5,000 seconds it takes to run. For the very small one, Fortran outperforms my Python script. It's faster here because Fortran is compiled and it's very fast and everything is just very fast, but it's doing. But as soon as we go up to 10,000, you see already Fortran is considerably slower, 1.3 versus 0.3. And then if you increase the size, then you see a big difference. 2.5 seconds in Python, Fortran goes up to 2 minutes. And if you go to 1,000,000, then it takes you still only 24 seconds in Python, but about close to like something 3 hours in Fortran. Now it's a big difference because you use a totally different algorithm. Because writing an algorithm, I think it would be unlikely that somebody who's a typical user would do it. So we do it on a linear scale because the log scale looks kind of very flattering to Fortran. That's a linear scale, and you can see here that's the difference. So the Python just takes like this, and the Fortran kind of takes forever. You get your processors working there. So you see the difference. So and we have the ratios. Those are the ratios between the runtimes. It gives a very nice straight line. So we have the ratios between the runtimes, and you can see here for small cases, this means Fortran is faster, and this means Python is faster. And you see it's close to a factor of 1,000 or 900 something up there. Then you can see the difference between the speeds we have. Okay, then again I compare the ratios in linear scale, and you see, yeah, it should be. Maybe I didn't update the graph, but it's a much different result there.
Excuse me.
Yeah.
I don't see the point here. You're comparing different algorithms.
Yes. Yeah. That's a point because the algorithm in Python is a set which is built in, and you don't have anything like this in Fortran. You could, but this doesn't. Yeah. Yeah. Exactly. Yeah. But the effort to do this in Fortran, that's how most people I talk to, most scientists in Fortran would do it. They would go through and would have this quadratic algorithm doing things. That's a point because this other algorithms like using a set as I do in Python, that's not as common in Fortran. That's a whole point. And people would do this, and I saw a lot of people doing this. Very similar things that people understand.
Some people don't know if there is a set Python, but also use the same algorithm.
Yeah, if you don't know, but set is it's a part of the standard Python. It's built-in Python type. So this is something that's more likely that people use. But most people that use Fortran, there is no type that helps you to do the things. Yeah. But it's exactly the point. Otherwise, if you would but you see the effort for me to write it already in Fortran. And if you would write another algorithm, you have to figure out the algorithm, you have to write the algorithm yourself. And if it's just a small script, you do something, just you want to figure out like a one-off thing like you can do in Python, then it would be a lot of effort to do this.
Yeah, it just seems a little unfair to me.
Yeah, it's unfair. Yeah. Yeah.
The problem is more suited for Python environments. So, like reading files, it's one liner in Python. Then you have to go through all these trouble in Fortran.
Yeah.
If I can, if it's possible, if we can move the technical description for after the meeting. Thanks.
Yeah, so I'm pretty sure anyway. So that was my point. So of course I'm cheating. That's what I'm saying. So I'm not I'm comparing apples to oranges. But that's of course it's not a scientific comparison of algorithm. That's what I said. But it's more or less for the most common case. People write algorithm. They do it like this. That's my experience. And I saw a lot of people that are very experienced in Fortran, and they write similar algorithms like this, like I did here. So they don't go and they check for some kind of more advanced, especially if it has to be just some one-off thing you want to compare. And most of the time you test your things with small amount of data and it works. You see, the small one, Fortran is very fast, much faster than the Python version, even the algorithm is not very favorable because Fortran itself compiles fast. But so it's not realistic. Can I use a better algorithm than Fortran? Exactly your question, that's why you're here. And there are no sets or anything built in. It's not nearly as easy. You have to go and figure it out yourself. And I found the implementation of a set in Fortran, but it uses the same algorithm as I use. It's the same quadratic thing. It doesn't really help, because it's going through everything and counting, and when it finds it returns. So it's doing pretty much the same as what I do here. So there's doesn't make any sense to use the external library with dependencies and do things, because won't be much faster. So, or would be pretty much the same. As I said, because Python uses hash tables, then you could do something like this, a hash table implementation, but the one I found is very difficult to use, and also says seemed to work, but it's not well tested and has a lot of limitations what you can do. You can have to convert everything to strings and work with strings and stuff like this, and it's very unlikely that a scientific user. Of course, once you use this one, that would give you another, I don't know, a lot of lines to do it, then you will be faster on Fortran, but the question, do people do this? That's my point here. So that's the common use case. Yeah, so it's very restricted. So it's difficult to use. So it's not realistic to assume that people are going to do this. That's my point here. And conclusion. So depends what you're doing. Python is not necessarily slow, and Fortran is not necessarily fast. It depends on the standards you compare. So if you do numerical calculations, so we did. Yesterday I did a optimization thing, and then you see that for numerics Python can be pretty slow, and these other techniques you can get much faster. But algorithms are important, and algorithms are much easier to write in Python. A lot of things is built in. You don't have to bother about the algorithm, which in the set has an algorithm built in, and you can do this there. And practical algorithms concerns are important. So you want to have it fast. You just want to compare your things, and you want to do this, and you don't want to write 100 lines if you can do it in 8. And in this realm, that's my opinion, just to say Python can beat Fortran. And this is a message that maybe people that are in this area, it would be very interesting for them to see that it's possible to get very efficient algorithms in Python, which are kind of not that likely to happen in Fortran. Okay. Thank you very much. Questions?
Okay. We have 4. We begin from here.
Okay, so being a programming physicist myself, I know what kind of code people not proficient in programming write. I give you that point without any question that the Fortran algorithm is a realistic example. But there's the famous saying that the real determined programmer can write Fortran programs in any language.
Yes.
And I'm quite sure that the same people would write quite the same algorithm in Python without even bothering to look at is there an efficient implementation already. So I think if you make that point that it's typical for a scientist to program like that, it's also valid for the Python version then.
Yeah, that's the point. But that's why I said but the sets is a standard part of Python. So if you learn Python yourself, and I saw a lot of Fortran code written in Python. It looks pretty ugly. So everything is full of globals. Everything is Fortran style. But if you teach the people a little bit about Python, so in my course I always teach sets. And especially for scientific users, it's very interesting. And I always have some examples that's similar to this. And this is a very eye-opener for them. Then they can say, okay, this algorithm, you get a lot of speed, and you don't have to go and write this 100 lines of Fortran to get this out. That's why they try. Of course, that's why the title was formulated a little bit like to get people interested in and see how it works. And I deal a lot with scientists, and as you said, they would do it, and they would write the same algorithm exactly like this in Python. But if you teach them a little bit, but teaching them writing the algorithms themselves in Fortran would be way more difficult than just using a set and say use AND and then you have intersection. Yeah.
So I have two comments. The first was when I saw the source code. I saw you using if and if with a space in between, although we all know that in Fortran the white space is not relevant. But on the do loops you used and do without a space, and it did not colorize correctly. That's just a remark.
Yeah, okay.
Do you have some reason to do so? That's the first part.
Not really. So it works with a space and without a space. Both is and if it's not colorized, then pigments just didn't pick it up. That both are it's valid Fortran.
So is there some coding guide for Fortran? Do they use and do?
If you look in books, it seems like some books they write everything that's a keyword in capital letters. Okay. Very often they have a book like this, and other books are different. Some put it together. I'm not aware of coding guidelines. Maybe there are some, but if you look in different books, they have different kind of ways of doing it. So. And
the second remark is, I'm not sure. I doubt a little bit that the scientists are that dumb to implement an algorithm with square behavior. I would have included, to be fair, a simple sort algorithm and then compare who wins in the end, because I think there's even a sorting algorithm in the library of Python, of Fortran, that could be applied before.
Yes, but I have seen something like this very often. Okay. I have to say. So of course, if you do some more advanced algorithm with Fortran, then it will be faster. That's no doubt about it. But it takes you more effort to do it. That's a point. Yeah. So but it's easy for very often they start with small data sets. They work with a few hundred, and you don't even see that's slow because it just works. And then if you really go with big data, then this thing explodes. And yeah. So do you rewrite everything? Depends. Yeah.
Other question?
About this example, it would be nice to see a more complete profiling of the code to see maybe what happens in memory, just in memory, without taking into account access to disk. Yeah. And then about Fortran and Python, under my experience, most of the time, we can introduce Python just because there is a lot of people having a lot of Python, but they don't want to a lot of Fortran, but they don't want to touch it anymore. So most of the time it's a matter of wrapping existing Fortran code and giving new interface, new way to access it.
Yeah. So actually, I do it myself a lot. I wrap existing. I did 10 years ago. I wrapped existing Fortran libraries with F2Py and give it a nice Python interface, and you use Fortran behind it. Because you don't want to touch it. You look at it, and I work half a year with a Fortran code, and it's still very difficult to understand what's going on because everything is so big, very, very big files, and very difficult to understand. And they have decades of history in this Fortran files, and it's very difficult to do. You give it a Python interface, and then you do everything outside in Python.
Okay, so most of my big calculation code is all done in C++.
Yeah.
And while in the middle of doing all that, the C++ got its upgrade with a standard template library where you then did get these sorting algorithms, and I have vast amounts in using that. And I was just curious as to whether you should be comparing with C++ rather than Fortran as a fairer balance.
Yeah, so if you use C++ and you have a strong library behind it, then of course C++ is faster. That's no question. But a lot of people still work with Fortran, and a lot of some seem kind of to just jump between Fortran 77 and Fortran 90. So you use very kind of you have a lot of old code, and people tend to program as what they see. That's what my experience is. So maybe if people work with C++, which is more complex than working with Fortran, I think so. But a lot of people, they don't know any C++. They don't know C. They don't use C. They don't use C++. They know Fortran, and they won't do anything else. That's my experience.
Other question? Yeah. No.
Hello.
Yeah.
There were some points made about. Right, I think someone said writing Fortran programs in any language, and I must agree, my personal experience working with my colleagues in physics, they will write stuff that's quadratic, 4x in, or 4y in, and duplicate the loops. It does happen, I've seen it. And they still do it in C, some horrendous C code. And I'm in the process of trying to set up in my university, some very small tutorials for moving from something like C and Fortran to Python. Do you have any brief recommendations about how to go about doing that? Because I think it's been hinted that programmers, scientists, need to change a little bit the mindset in order to use features in Python that are clearly in Python, like sets.
Yeah,
thank you.
That's a difficult thing to do. It depends very much on the person. Some people are open to this. Some other people, they always have to done this like this, and it's good. There are two different opinions, but that people do. But my thing is, I just give them small examples like this, and they work, and they can understand. And scientists often are very pragmatic. They don't look at theories and anything. Just if you give them some working examples and it works, and they can change it, they can do something with it. That may be the easiest thing. So if you solve a few of small problems like something like this, or similar problems with Python, and you explain to them fully how this works and how they can modify it with a lot of work, that might be an approach. So it's a very pragmatic approach to give them a solution to a problem they have, and the solution is better, easier, and even faster. So that's one of my things. Yeah.
Any more questions? No? Okay. So thank you for your speech, and thank you for participation. Thanks.